So now let's learn JavaScript. So what is JavaScript? JavaScript is an interpretive language, not compiled, meaning that it will not compile into a binary executable file. If it did, it would need to compile the entire interpreter as well, which would completely defeat the purpose. So an interpreter is like Node.js, Deno, etc. I'm about to get to that. So originally, JavaScript was built for building web pages or giving them more complex features. Now it is used almost everywhere, from web apps to mobile apps to servers, etc. There are three common runtimes: Node.js, Deno, and Bun, all of which run natively and outside of a browser, so they are not sandboxed to the web page. They can access files, they can access the internet, they can do all sorts of really cool things. So this is what I was talking about before. These are basically, essentially, it's a browser that's reading JavaScript, but it's also not soundboxed. But it's not, you don't have like the web page that you're interacting with. But what I'm describing is Chromium, the V8 engine, etc. It all operates the same way as the browser, but it is just spawn and it's a native application. So if, as I was saying before with the not compiled thing, basically you would have to ship the entirety of Node.js or the entirety of Deno or the entirety of Bun along with the application you're trying to run, which now your file's massive. Whereas if you're trying to write something at a lower level and make it fast and compile it into a binary executable, it'll be a lot smaller if you write it in Rust, if you write it in C++, etc., because you don't have an interpreter that needs to interpret what you wrote. So after this, there are builds that run JavaScript natively for like applications in mobile or like on Android devices, iPads, etc. These are called, one is called Tari and the other one is called Electron. And there are others, but they basically spawn lightweight browsers controlled from the backend, controlled from backend code. This means that, these are meant for native and mobile applications. That's what I said. Okay, well, I'm repeating myself. That's all right. So basically, this is a lightweight browser that is controlled through another little thing that, well, obviously controls it. Okay, so these are three different ecosystems. Essentially, they have similarities, but web pages is inside of a browser. We call that the front end code. We would also call this, at least Tari, the front end code. Electron, I think, runs back end stuff as well. I don't remember exactly how it works. I haven't used it. This is all back end code. Okay. And this is, Tari at least, is front end. Electron, I think, ships with Node.js or something like that. And it has back end code as well. So, why JavaScript? It is versatile. Due to the different runtimes and build ecosystems, it is able to be deployed almost anywhere. Because of this, if a user is fluent in JavaScript, they are able to work in many different areas of computer science. It is easy for beginner students to learn fewer languages when they start, so we use JavaScript for both the front end and the back end ecosystem, or the front end and back end builds. So now you don't have to learn a new language for the back end as well as the front end. Whereas if you were learning it doing Python, you'd have to learn a different language for the front end and back end, which can help sometimes, but I kind of want to make it simpler for us, and so at least in the robotics team, we are using Node.js on the back end and TypeScript on the front end, or obviously JavaScript on the front end. So you also don't have to worry about memory very much, since you have a little helper, the garbage collector. Basically, it is just a little friend that follows you around everywhere, picking up all the trash you throw on the ground after you're done. So basically, in JavaScript, you can think about it as if you're walking around eating a big sandwich and you keep dropping crap everywhere. And those pieces of things are like memory pointers that you're not using anymore, that you don't care about. And so the garbage collector takes those and throws them away just to clean up memory, which is often very helpful. You don't have to say, hey, I am assigning that part of RAM to be this exact thing. You don't have to deal with memory. You just don't. It's quite helpful. JavaScript is also, garbage collector. Okay. JavaScript is also designed to be fully backwards compatible. So if you write something, in theory, it will always work. the stuff that was written 20 years ago works to this day because of JavaScript, okay? However, this has a major downside. Full backwards compatibility means every decision that was made when adding onto JavaScript must stay. Because of this, it is easy to be confused as to what's happening. So, there are some weird decisions that are permanent in the ecosystem, like how type coercion works. However, there are ways around that. In addition, you have confusing syntax at times. But again, there are ways to address this. The garbage collector can cause significant performance issues. If you are at the point where it is your obstacle, you should move to a different language and runtime. Obviously different. Well, okay, so you could switch to Python, which basically Python can call lower level languages, and that's why it can be faster. But it also has a garbage collector, so you have to make sure you're writing it well. But if you really want to just get rid of the garbage collector and not worried about it at all, you'll move down into something like Rust or C# or something like that, where you have to deal with memory. And it's just inherently faster. In addition, JavaScript is not inherently type safe. This makes it very easy for dumb issues to arise at runtime. However, TypeScript is here to save you. However, if you're not careful when using TypeScript, you'll just completely defeat the purpose. Like, I hate the any keyword. So stupid. It's the worst thing ever. Just beyond terrible. I understand why it has to exist, but it's dumb. So, you may wonder why they can't make a new version of JavaScript to get rid of the mistakes of the past. The issue is that you have no idea what web page there is deployed out there in the world that is relying on one of those features that an entire economy depends on. So if JavaScript changes, now all of those old pages must be updated, and that is a massive task. So JavaScript gets updated, all of those web pages go down, and maybe some of that information or some of those web pages are just essential for something out there in the world, and basically JavaScript, you can't do anything to it other than add on to it without destroying anything previous. So that is a major con of JavaScript, is its backwards compatibility. But it's also one of its major upsides, is that everything from back then works. But it also sucks because we have these weird decisions and weird things happening. So, yeah. So, what is a garbage collector? I just want to briefly explain what's going on. A garbage collector is how interpretive languages manage memory. Instead of programming directly and interacting with memory pointers, the interpreter will manage all of those pointers, and once they are no longer needed, it will clean them up after the scope is over. This is both good and bad. So, yeah, I already said that. So this is both good and bad. It makes it so you can easily write scripts and not worry about memory, but if you're trying to write performative applications, the garbage collector will slow you down. So there are a couple of alternatives to pure JavaScript. If you want type safety, you, like you see in most other languages, use TypeScript. It basically it works. It has the same syntax with some added stuff onto it. But it has stricter types and checks. So you can create custom types that aren't read in runtime, but they are used to compile from TypeScript into JavaScript, and that compiler will go, oh, hey, you have a failure here. You need to fix that. You have some weird type going on here. Fix that. And then you also have various other things like ESBuild and linters and formatters and crap that will help you write your code well. So another thing you can do for front-end JavaScript is to use frameworks. So if you're not careful when writing front-end JavaScript, it's very easy to get into like bad paradigms and stuff like that. And that's where these frameworks can help you. So Svelte, React, Vue, Angular, these are basically, it brings simplified features and nice looking, I'm reading the wrong thing. All of these use JavaScript or TypeScript, but they abstract several aspects away from several aspects of JavaScript away to make it easier on the programmer. So like Svelte, all 4 of these use like components, and basically you can think about it as what is the concept? Imperative versus declarative. So JavaScript is very easy to be imperative. So it has a bunch of, you basically write a step-by-step whatever to do what you want it to do. Whereas these frameworks bring that, take that and compile it into a neat little package. And so you don't have to write this step-by-step every single time. So Svelte has, all of these have reactivity, and so you like change a certain state of a variable or whatever, it will redo the view. Okay, this is just very helpful for us as developers, because it gives us the declarative aspects, or it gives us a declarative API for us to interact with the web browser. Which, if you don't know imperative versus declarative, I haven't made the video yet, but I will. Watch that video, which is funny because maybe I'm going to forget about that video and not do it. But you can look it up. Imperative versus declarative. So, this is what I was reading before. Notice how I didn't put Bootstrap on here. Wow. I'll say that 5 times fast. Bootstrap is not technically a JavaScript framework. It brings simplified features and nice-looking components, but it is unlike those others which are written up above or over here, because it doesn't have a virtual DOM. We will get into this later, but basically, all of these have a declarative way to interact with the view and manage the state, whereas Bootstrap doesn't have that. It just gives you components and a cohesive view that is just static in a way. And it also gives you features and nice looking things. So anyway, if you want a more performant front end, use WebAssembly. With WASM, you can basically, or WASM, I don't know how people pronounce it, but I pronounce it WASM. With WASM, you can basically turn your front-end code into a much more performant system. Essentially, WASM is a binary file that is served along with the other parts of your site that runs at a lower level. However, it is still sandboxed for security reasons. So, basically, JavaScript is slow because it has a garbage collector, but you can send it like code that is compiled from Rust, and it compiles into a WASM file that you send along with your site, and that WASM file is run on that on the browser, or sorry, on the end user's computer, and it'll run faster because you don't it's a lower level language. So, all of that said, let's get into JavaScript.